The traffic light PLC program. Every textbook has it. Every interview asks about it. Every beginner builds it. There is a reason. The traffic light is the cleanest introduction to state machine logic on a PLC. It uses timers, sequencing, mutual exclusion, edge cases, and structured ladder all in one program. By the end of this video, you can build the full two-direction intersection in a free simulator, plus the pedestrian crossing, the vehicle detector, and the all-red overlap that turn it into a portfolio piece. Start with the simplest fact. A traffic light has 3 states per direction: red, yellow, green. Never 2 of them on for the same direction at the same time. The transitions are fixed. Red goes to green. Green goes to yellow. Yellow goes back to red. Never red to yellow. Never green to red. The fixed transitions are what make this a clean state machine. Each state has a duration. Green is the longest, maybe 30 seconds on a real intersection. Yellow is the shortest, 4 to 6 seconds, depending on the speed limit. Red is whatever is left while the other direction is going. The cycle repeats forever. Now add the second direction. North-south versus east-west. 6 output coils total. NS_red, NS_yellow, NS_green, EW_red, EW_yellow, EW_green. The critical rule is mutual exclusion. NS_green can never be true at the same time as EW_green. Same for yellow. The way to guarantee this in ladder is a state register. An integer tag tracks the current phase. Phase 1 is NS green and EW red. Phase 2 is NS yellow and EW red. Phase 3 is all red. Phase 4 is EW green and NS red. Phase 5 is EW yellow and NS red. Phase 6 is all red. Then back to Phase 1. The timers drive the phase transitions. Each phase has a TON timer with the right preset. Phase 1 timer has a 30-second preset. Phase 2 timer is 4 seconds. Phase 3 is 2 seconds for the all-red overlap. Phase 4 is 30 seconds. Phase 5 is 4 seconds. Phase 6 is 2 seconds. The active timer's IN is wired to a contact that reads the state register equal to that phase number. When the timer's Q output fires, an OE moves the state register to the next phase. The previous timer's IN goes false because its state no longer matches. The new phase's timer starts. State machine done. Every output is gated on the state register, so mutual exclusion is automatic. Edge case number 1 is the pedestrian crossing, a pedestrian button on the corner. When pressed, the program holds the current cycle through to the next all-red overlap, then extends that all-red by 10 seconds for the crossing. The walk signal lights for the first 7 seconds. A flashing don't walk for the next 3. Then the cycle resumes. Implementation is 1 extra phase in the state machine. State register adds a value for the pedestrian phase. The pedestrian button input sets a latched bit that gates entry to the pedestrian phase at the next opportunity. The latch clears once the phase completes. Press the button at any time. The system waits for the right moment, then accommodates. Edge case number 2 is the vehicle detector, an inductive loop under the east-west road. If the loop has detected no vehicles in the past 60 seconds, the east-west green phase is cut short, from 30 seconds down to 15. This is how real intersections give priority to the busy direction. Implementation is a separate timer that resets every time the loop senses a vehicle. The Phase 4 duration becomes conditional. If the vehicle recently detected bit is true, use the 30-second preset. If false, use the 15-second preset. Same state machine. 1 extra condition on 1 timer's preset. Real intersections layer multiple of these. Vehicle density timing. Time of day timing. Emergency vehicle preemption. The state machine handles them as additional phases or conditions on the phase durations. This is where the traffic light becomes a portfolio piece. The basic 2-direction intersection with state machine and timers is the textbook version. Showable. The version with pedestrian crossing plus vehicle detector plus all-red overlap is the interview-worthy version. Publish the rung diagram on GitHub. A README explaining the state machine. A short video showing the cycle running. A test plan covering the edge cases. Hiring managers love this kind of portfolio piece. It proves the candidate can take a textbook problem and add the complexity real machines have. 5 hours of work. Lifetime CV value. Build the full intersection free at plcsimulationsoftware.com. The simulator includes traffic light examples on the free tier. Run the cycle. Add the pedestrian button. Wire the vehicle detector. Test the all-red overlap. Once it works in the simulator, screen record it for the portfolio. Next video covers HMI programming basics, the second half of a real controls programmer skill set. Subscribe. New video every Tuesday. See you in the next one.